Hello, I'm Andrea, a primary educational student at the University of Murcia, and today I present my educational project, Green Points in Augmented Reality, which integrates three different technologies: digital comics, augmented reality, and robot programming. That is for my final exam of Resources and ICT. And it consists of two different parts. The first one is the project and the second one the reflective one. So let's start. Let's start with the first part of our project. We are going to make a brief introduction. We'll start with a participatory talk. For example, what space do you know and how can we care of them? And then I present the talents: adopt and improve a natural space using technology. We conduct a brainstorming class session in terms, and then I will explain what they have to do. So the first task is the comic, then the augmented reality, and finally robot programming.
This project is designed for a 5th grade school group with one student with ADHD that will work with clear instruction and keywords in blood, another student with dyslexia that will use Arial font with spacing and short sentences, and finally the rest are average bilingual students with strengths like visual and mnemonic learning. With this project we are going to work with some curriculum objectives that are civic values, environment knowledge, artistic education, and digital competence. This is the rubric that will be used to evaluate the final project and all the activities completed by each group. The evaluation will cover many important aspects. These include how original and creative the project is, how well the team worked together, and how complete and effective the final result is. The goal is not only to create something of high quality, but also to show that the group was organized, responsible, and able to solve problems during the process. Each part of the project will be taken into account to give a fair and complete evaluation. In order to create this project, I have asked to ChatGPT. I asked, how would you design an interdisciplinary project for 10 years old using comics, AR, and programming to explore environmental care? The AI proposed a motivating, creative, and practical sequence. After analyzing it from a constructivism and PBL perspective, I decided to keep the core structure, adapting examples and material to real profile of my student. The first step to start this project is to create a comic. The first step will be to create their own story, which they will later adapt into a comic. Each student will think of a short, creative story related to the environment or recycling, something they enjoy telling. Once they have their story, they will begin designing their own comic panels. To do this, they will use the artificial intelligence tools they like the most, allowing them to bring their character and scenes to life with their own unique style. When the panels are ready, they will organize them in Canva, arranging the comic in the order that makes the most sense for their story. And finally, once everything is complete, they will create a QR code so they can easily access and read their comic on any device. Now we are going to move on to the next activity, augmented reality. So let's start with it. First, we create a new project to start building our green point. This will be the base of our game. We will design the space and add everything we need to start recycling. Next, we choose the environment we like best. This will be the background of our game. It can be a park, a street, a beach, any place where we imagine our recycling mission taking place. Now, it's time to insert all the objects we like to build our green point. We can add trees, recycling bins, science, and anything else that help us create a fun and colorful place for our game. As we add each element, we will adjust both its position and its size. This way, everything fits nicely on the stage and our green point look just the way we want it. One important thing to keep in mind is the camera's position. The camera shows us the part of the scene we will see when the game starts, so we need to place everything carefully to create the perfect view for our players. Finally, we will add speech bubble with messages that encourage people to take care of the environment. This can be short and fun phrases. So here we have our last task, virtual robot programming. We are going to create a robot, we are going to add a robot and trust sprites. We are going to program its movement, configure scoring variables for each item collected, but this activity is going to be guided. We are going to do it in class. Let's start creating our recycling game in Scratch. The first step is to delete the original character and choose a new one, the one that we like the most. Once we have it, we give it a fun name that we choose ourselves. Next, we add a background to our stage to make the game more colorful and interesting. After that, it's time to add the recycling bins. Since Scratch doesn't have them by default, we will copy and paste images from the internet. We will use 3 different bins, a green one for glass, a yellow one for plastic, and a blue one for paper. Now let's add the trash. These are the objects that our character will collect. We can place them wherever we want on the screen. To keep everything organized, we will also rename each bin and each piece of trash. And now it's time of the most exciting part, the programming. It might seem tricky, but we will go step by step. First, we use the yellow event block when key pressed. This block will let us move the character with the arrow keys. For example, if we want to move right, we will use the right arrow key, and the same for the other direction. Then we program our character so that when it touches a piece of trash, the trash will follow the character as it moves toward the correct recycling bin. Once the character reaches the bin, the trash will disappear, just like it was dropped inside. We repeat this process for all directions, up, down, left and right, so the game works no matter how we move. To make the game even more fun, we will add a score counter. We do this in the variable section by creating a new variable, like score or trash collected. Now, every time we recycle a piece of trash, the score will go up by 1 point. Now we are going to talk about the PICRAT analysis. PICRAT is a simple way to think about how we use technology in school. It helps us see what students do with technology and how technology helps learning. Let's explain PIC, what students do. There are 3 levels in PIC: passive, interactive, and creative. Passive, the student just watches or listens. In this project, we avoid passive activities. Interactive, the student touches, moves, or answers something using the computer or tablet. For example, using Canva to read comics or working with AR, augmented reality. And finally, creative, the student makes something new, a comic, a game, a robot, or a digital exhibit. The student becomes the author. And now, RAT, how technology helps learning. There are 3 levels in RAT 2. Replacement, amplification, and transformation. Replacement. All tools are changed for digital ones. For example, reading a comic on screen instead of paper. Amplification. Technology makes work easier or faster, for example, using Scratch to code or edit. And finally, transformation. Technology creates something new that wasn't possible before. For example, AR brings 3D objects to real life, changing the way we learn. As I said, comics are creative and amplification. Students create digital comic and share via QR. AR, interactive and transformation. Design and explore enrich real-world scenarios. And finally, Scratch, creative and amplification or transformation. Program virtual robots, transforming their understanding of robotics. It has a very huge learning impact. For example, student agency. Each student is the author of their own digital artifact. Metacognition. Students reflect on their creative and technical process. And finally, transfer. Students apply digital skills to real contexts and future projects. Now we are going to move on to explain the pedagogy, how we learn in this project. In this project, students do more than just listen. They think, explore, and create. They are the main character of their job. So let's look at how they learn. With project-based learning, students have a challenge: adopt and improve a natural space. So they follow the following step: define the project, plan AR points, research, and create something new. With this method, students learn how to be independent, how to manage their time, and how to think critically. Socio-constructivism. Teachers help with mini lessons and rubrics. Students work in teams and help each other. After each part of the project, the group talk and reflect on what they did and what they learned. This way, students learn together and grow step by step. Experimental learning. Students learn by doing. They following the learning cycle: experience, reflect, think, and try again. It helps them understand better and improve with every step. In inquiry-based learning, students ask lessons and try to find answer. They follow the following step: ask a question, collect data, and create a solution. This method helps students become a good researchers and better thinkers. Collaborative learning. Students work in teams. Each student has a role and a task, and they learn how to listen, share, and take responsibility together. Student-centered design. Students make choices. They choose the space, the tools, and the message they want to share. They learn with real-world activities, not just books. So learning becomes personal and meaningful. So in conclusion, this project uses many ways to help students learn better. They work together, think deeply, and create things that matter. When we use digital tools in school, it's important to make sure that they are safe, respect privacy, and have fair rules. This table shows 4 tools we use and checks 3 important things. But in conclusion, all tools are useful, but Scratch and Canva are the safest and most school-friendly. CoSpaces is also good for education. CapCut can be fun, but it's not designed for children or schools. Finally, we have the ACA toolkit that helps teachers plan learning activities. It looks at 3 parts: what students do, tasks, what students they use, materials and tools, and how they work together alone or in groups. And this helps make learning better for students. So to conclude part 1, I summarized the key points. We defined our students' profile, aligned objectives with the decree, presented each phase of the project, and analyzed each pedagogical value using RICT and the RICT framework. This work demonstrates an active, inclusive, and transformative learning approach, preparing students as agents of change in their natural environment.
Now we are going to move on to the next and last part of the final exam. This is the reflective one, in which we are going to talk about some of the aspects of the course. I've chosen the question number 2, the question number 3, and finally the question number 5. During this course, I have learned many interesting and useful concepts, but from my point of view, the most important ones are 2 theoretical and 2 technological, that are data literacy, TPAC, augmented reality, and programming. Let me explain each one and how can I apply them in our projects. So let's start with the theoretical concept. The first one is data literacy. That is the ability to read, write, and communicate data in context, with the understanding the sources, the analytical methods, and techniques applied, and the capacity to describe the case's implementation. In simple terms, is the ability to read, work with, analyze, visually represent, and discuss data. In our environmental project, data literacy was especially relevant when thinking about how a student could reflect on what they collect. For example, after playing the recycle game, they could create simple charts to compare how many plastic, paper, or glass items they have collected. This helped them understand the impact of the waste and start thinking critically about the work around them. The second theoretical concept is TPAC, which stands for Technological Pedagogical Content Knowledge. The TPAC frameworks aim to acknowledge the nature of the knowledge teachers need to integrate technology in their instruction. Moreover, it's emphasized that there is no correct way to implement technology in an educational setting. When I designed a Scratch game, I used TPAC without even realizing it. I had to know about recycling the content, choose a fun way to teach it, game-based learning, and use Scratch, that is the technology, to make it all work together. TPAC helped me to create an experience that was meaningful, funny, creative, and educational at the same time. Now, let's move on to the augmented reality, or AR. There is a type of technology that allows us to add layers of visual information over the real world around us. This information can be viewed for various devices, such as our mobile phones, for example. In our project, we create a simple AR experience where a student could scan their QR and see their own landscape with some motivated sentences. This made the activity more engaging, interactive, and helping them learn exploring by playing. And finally, programming. One of the tools that I use is Scratch for my project. That is, educational or pedagogical robotics is a discipline designed so that the student from an early age become familiar with robotic devices, technological resources, and programming in an interactive way. In my case, I built a recycling game where a character had to pick up the trash and sort into the right bin. This project helped me to learn how to think logically, organize action using code, and design an experience that both is fun and educational for younger students. Throughout this course, I developed not only specific skills and projects, but also a clearer idea of how I learn tools and which tools support me best in the process. That's what a personal learning environment, or PLE, is. According to Adwell, a PLE is a system that helps learning take control of and manage their own learning, including how they set goals, organize content, and communicate with others. So, thinking about everything that I have done during the course, here we have the 5 key elements that I believe should always be part of my PLE. The first one is Scratch. It has been one of the most powerful tools I have used. It allowed me to create educational games from scratch, literally. It made me feel confident using code to communicate ideas, to design learning experience in a playful and accessible way. So Scratch showed me that programming doesn't have to be intimidating. The second one is Canva. Canva became essential in its chat that I have made. It helped me organize content visually and spread creativity in a way that feels like professional, even without graphic design experience. It's a perfect example of how technology can support both communication and design in education. The first one, of course, is artificial intelligence tools. AI is probably the most used tool during the course. They allow us to experiment, imagine, and produce quickly. I see AI becoming a long-term part of my PLE, especially for creative projects or brainstorming ideas. Now, Google Drive. Google Drive helped me keep all my materials organized, self-file with my classmates, and collaborate easily. It's not just about storing files, but it's about organization and teamwork. That for me, it's key for any project. And finally, future tools, like for example, augmented reality. I think that it's very important that my PLE stays open to new tools and technology. For example, the AR experience we created gave me a glimpse into the future interactive learning. In the medium or long term, I want to keep exploring tools like this to stay updated and push my learning further. To sum up, my PLE is not just static, it's dynamic, creative, and constantly growing. These 5 elements, Scratch, Canva, Google Drive, AI, and future tools, reflect who I am as a learner today and who I want to become, or at least I think so. First, I believe that I deserve a grade no less than 9 out of 10 because I've worked constantly throughout the course, not only finishing its tasks, but always trying to be creative and meaningful in every project. I designed for the final exam an educational game with Scratch, created a comic using AI tools, worked with augmented reality, and always tried to connect everything to real learning goals. During each activity I made along the term, I've put effort into everyone, and I believe that the quality and originality of my final work reflect that. Second, the most challenging role I took in this course was definitely the analyst. I had to reflect and evaluate. Being an analyst wasn't just about doing things, it was about understanding why and how they help us grow as education, and the worst part, evaluating all the members of my group. This really pushed me to think critically, but the reality is that I couldn't be a bad mate with them. Finally, about using AI in this exam, yes, of course, I used AI tools to help me organize ideas, get feedback, and improve my writing. But AI didn't do the work for me. It was more like a partner. I brought the idea, the personal experience, the creativity. AI helped me polish and clarify them, so I would say that my humanity gave meaning to the AR's idea. In the end, the reflection, like the whole course, showed that technology is a great ally, but our human side gives purpose. So that's all about my final exam. I hope you enjoy it, so thank you very much.